Okay, this is questions number 19 and 25 on page 25. Both have similar directions, but the first part is different. So for number 19, the directions are asking you to find the distance between the 2 points, but it's asking you to use Pythagorean theorem. So first of all, you need to realize that Pythagorean theorem is only used for right triangles. The 2 legs are A and B, and the hypotenuse is C. The order of A and B doesn't matter. You could have A over here and B over here. So here's Pythagorean theorem, A squared plus B squared equals C squared. Okay, so for number 19, it's asking you to find the distance between the point 0, 0 and 8, 6. So the distance is really what we're trying to find is how long is that line between those 2 points. That's what the distance is. So to use Pythagorean theorem, what you can do is just revert back to something that you know, which is slope, rise over run. So if I rise and I use my run, if I count, my rise would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And my run is going to be 1, 2, 3, 4, 5, 6, 7, 8. If you want, that gives you a right triangle. It's upside down. If you don't want your right triangle upside down, you could count your run first, which would be 8. And then you could count your rise of your slope, which would be 6. And now you have a right triangle that's upright. So whenever we're using Pythagorean theorem for the distance, we're always going to be looking for the hypotenuse, which is C. So then I can just do 8 squared plus 6 squared equals C squared. Order of operations, exponents first, 64 plus 36, and that's going to give us 100. And to get rid of a square, you're going to take the square root. So the hypotenuse of that right triangle is 10, or that means the distance of that line is going to be 10 units, which means if you took your coordinate plane and you started at a point and counted down 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. So that would be 10 units on the coordinate plane. So this line right here is the same exact length as that line segment. Okay, the other question on page 25 is number 25. It's also asking you to find the distance between 2 points. It gives you the order pairs, but this time it's specifically asking you to use the distance formula. So each order pair is always x and then y. So here's your distance formula. So we're just taking those points and substituting in. So x sub 2, I'm going to use a 6. X sub 1, I'm going to use as negative 3, which really becomes a positive 3. Y sub 2, I'm going to use 5. And then y sub 1, I'm going to use 2. You could have yours backwards from mine, which just means in the next step your signs will be the opposite of mine. I use this as x sub 2, so I had to use this, the 5 as y sub 2. If I had used this negative 3 as x sub 2, then I could just, the y has to be the y sub 2. So I'm going to now just perform order of operations. I'm going to do parentheses first. And then I'm going to square. If you have negatives, I like to keep the negatives inside the parentheses. So 81 plus 9, which is now going to give us the square root of 90. So that line would be the square root of 90 units long. The directions don't tell you how your answer needs to be written, so you can leave your answer like that, or if you want to round to the nearest tenth, that would be 9.5 units. Which means, again, if I went back up to just a plain old coordinate plane, there's about 9.5. The distance between these 2 points would be about that long. And it doesn't matter where it is on the coordinate plane. You can change it and twist it, and it's still going to be 9.5 units long.